Hello everyone, Taylor here. Today we're going to be working through question 5 of the Spring 2019 exam. You are given the following information about random variable x. The hazard rate function is a piecewise function where when x is greater than or equal to 2, the hazard function is k squared over 3x, otherwise it is 0. Second, the value of the cumulative distribution function at x is 0.936. Calculate the absolute value of k. So first thing to point out is the absolute value of k. So just want to keep that in mind. That's the type of detail that I'll often forget in these types of exam situations. So I might highlight or underline that. But jumping into the solution, information you need to know to answer this question. One is how to convert a CDF to a survival value. So if you think of the CDF as the probability that you'll die before a certain time, so for a given t, what's the probability you died at or before that time, then the probability you survive past that time is obviously just going to be 1 minus that value. So that's how you convert CDF and survival values from one to another. Second, survival function is equal to e to the negative integral of the hazard function. That's definitely a formula that's been used, I think, on every previous MAS1 exam, so you definitely need to know these formulas. Third bullet point, just that the antiderivative of 1 over x equals the natural log of x. I think that for the most part this is the most complicated antiderivative you need to know. It's normally like polynomial terms, I think, for these types of exams. I'm not sure I've seen any trig antiderivatives up to this point. And then finally, bonus. So this isn't something you need to know to answer this question, but just conceptually to know what a hazard function is. The hazard function is, assuming you survived up to a certain point, what is the probability that you would die at exactly that point? So that's why you get this PDF in the numerator, so it's the probability of the event occurring at that exact moment, and then divided by just those who at least made it up to that point. So again, this isn't really needed for this question specifically, but just so you know what a hazard function is. So going into the calculations, really it boils down to this second formula with the e to the negative integral. That's what we want to get things to because we have the hazard function, and so that's why we need to immediately convert our CDF to a survival value. So that's where we get this 0.936. We just do 1 minus that equals, and then we plug in our hazard function. Since it's piecewise, that is why you see this integral going from 0 to 2 and having a value of 0, and then separately integrating from 2 to 5 with the hazard function of k squared over 3x. We take the natural log of both sides, multiply both sides by -1. Then finally the integral from 0 to 2 of 0, the area under the curve of 0 is just 0, so that just goes away. K squared over 3 is a constant, so actually you could just pull that out, and then all you're left with integrating is that 1 over x, which we already discussed is just the natural log of x. Integrating from 2 to 5, take the larger value, natural log of 5, subtract the smaller value, which is the natural log of 2. And then at this point, it's just more basic math. So we're going to multiply both sides by 3, and then divide both sides by the natural log of 5 over 2, and we just get 9. K squared equals 9, so then we say k equals plus or minus 3. And this is why this question asks you to take the absolute value, so that way there aren't more than one correct answers. So taking the absolute value of -3 gives you 3. The absolute value of 3 gives you 3, and so it doesn't matter which one you picked, you should get 3 either way. Scrolling up, we see that falls in the range specified by C, so that is our final selection. That completes today's walkthrough for question 5. Thank you for watching, and please consider subscribing if you find these videos helpful. Thanks. Have a good one.